Northern Ireland has a fascinating volcanic history, though it doesn't have any active volcanoes today. The region's volcanic heritage is primarily from ancient geological periods. The most famous volcanic feature is the Giant's Causeway on the Antrim coast, formed around 50 to 60 million years ago during the Paleogene period. This UNESCO World Heritage Site consists of approximately 40,000 interlocking basalt columns created when molten lava cooled rapidly. The same volcanic activity created the broader Antrim Plateau, which covers much of County Antrim with layers of basaltic lava flows. These volcanic features resulted from intense geological activity when the North Atlantic Ocean was opening. Massive lava flows covered the landscape, and in some areas, the lava was so thick it created the distinctive plateau landscape still visible today. The columnar jointing at Giant's Causeway formed as the lava contracted while cooling, creating the hexagonal columns. Beyond the Giant's Causeway, you can find volcanic rock formations throughout the Antrim coast, including at Dunluce Castle and the Carrick-a-Reed area. The Slemish mountain in County Antrim is actually the solidified core of an ancient volcano, though much smaller and older than the Antrim Plateau volcanism. Northern Ireland sits on geologically stable crust and has no volcanic activity today. The nearest active volcanic regions are in Iceland, far to the north across the Atlantic. The volcanic legacy has significantly shaped Northern Ireland's dramatic coastal scenery and continues to attract millions of visitors annually to see these ancient geological wonders. The volcanic activity in Northern Ireland occurred in several distinct phases during the Paleogene period. The initial eruptions began around 62 million years ago, with the most intensive period happening between 58 to 55 million years ago. These weren't explosive volcanic eruptions like Mount Vesuvius, but rather massive flood basalt eruptions where lava poured out of fissures in the ground, spreading across vast areas. Northern Ireland's volcanic rocks are part of what geologists call the North Atlantic Igneous Province or Thulian Plateau. This enormous volcanic province stretched from Greenland through Iceland, the Faroe Islands, Scotland's Inner Hebrides, and into Northern Ireland. The lava flows were so extensive they covered an estimated 1.3 million square kilometers across the North Atlantic region. The Antrim Plateau consists of multiple lava flows stacked on top of each other, reaching thicknesses of up to 780 meters in some areas. Each flow represents a separate eruption episode. Between some flows, you can find thin layers of red rock called laterite, which formed when tropical weathering occurred during quiet periods between eruptions. There are also occasional thin coal seams and fossil plant remains, indicating that vegetation grew between some eruption phases. Beyond the surface lava flows, Northern Ireland has numerous intrusive volcanic features where magma cooled underground. These include sill complexes, horizontal sheets of hardened magma that intruded between existing rock layers, dikes, vertical walls of volcanic rock that cut through older formations, volcanic necks, the solidified cores of ancient volcanoes, like Slemish Mountain where St. Patrick allegedly tended sheep. The volcanic legacy has significant economic importance for Northern Ireland. The Giant's Causeway attracts over 800,000 visitors annually, making it one of the region's top tourist destinations. The basalt rock has also been quarried historically for construction materials, and the volcanic soils in some areas are quite fertile for agriculture. Northern Ireland's volcanic history is intimately connected to Scotland's. The same volcanic province created the dramatic landscapes of the Scottish Inner Hebrides, including the famous columnar basalt on the Isle of Staffa, which inspired Mendelssohn's Hebrides Overture, and the Coolin Mountains on Skye. You can actually trace the volcanic dike systems across the sea between the two regions. The area continues to be important for geological research. Scientists study the Antrim Plateau to understand how massive flood basalt eruptions work and the potential climatic impacts. Some researchers suggest that similar volcanic events in Earth's past may have contributed to mass extinction events, making Northern Ireland's ancient volcanic record valuable for understanding both regional and global geological processes. The basaltic rocks of Northern Ireland contain fascinating microscopic features that reveal the conditions during their formation. Under microscopic examination, the basalts show varying crystal sizes that indicate different cooling rates. The Giant's Causeway basalts contain plagioclase feldspar, pyroxene, and olivine crystals, with some flows showing distinctive glomerocrysts, crystal clusters, that formed before eruption. Some specimens contain zeolite minerals that formed much later through hydrothermal alteration, creating beautiful crystal-lined cavities called amygdales. The Antrim basalts preserve an important record of Earth's ancient magnetic field. As the lava cooled, iron-bearing minerals aligned with the magnetic field direction at the time of formation. Scientists have used this paleomagnetic data to help reconstruct how continents moved during the Paleogene period. Interestingly, some of the lava flows record magnetic field reversals, where Earth's magnetic poles flip during the eruption sequence. The composition of the lava flows changed over time, reflecting the evolution of the underlying magma chamber system. Early flows tend to be more primitive basalts with higher magnesium content, while later flows show signs of fractional crystallization and crustal contamination. Some of the uppermost flows contain slightly more evolved compositions approaching basaltic andesite. Geochemical analysis reveals that the magmas originated from partial melting of the mantle at depths of 60 to 80 kilometers. Beyond the famous hexagonal columns, the Antrim basalts display complex jointing patterns that form during cooling and subsequent tectonic stress. Vertical columnar joints dominate, but horizontal joints also divide the flows into distinct tiers. The diameter of columns varies with cooling rate. Slower cooling produced larger columns. Some areas show fan-shaped jointing where cooling progressed from multiple centers, and curved joints indicate local variations in the cooling surface. Between the major lava flows lie fascinating geological formations that provide windows into the environment between eruptions. The interbasaltic formation includes lignite, brown coal, seams up to 8 meters thick, indicating that extensive peat bogs formed during quiet periods. Fossil plant remains include ferns, conifers, and early flowering plants, suggesting a warm, humid climate. Some layers contain freshwater limestone with fossil fish and insects, indicating temporary lakes formed in the volcanic landscape. The original volcanic landscape would have been much more extensive than what we see today. Millions of years of erosion have carved away vast amounts of volcanic rock, creating the dramatic coastal cliffs and inland escarpments. The erosion patterns are controlled by the layered structure of the lava flows. Harder, more resistant flows form prominent ledges and waterfalls, while softer interbedded sediments create recesses and slopes. The famous glens of Antrim were carved by rivers exploiting weaknesses in the volcanic pile. During and after the volcanic activity, hot fluid circulated through the cooling basalts, creating secondary mineral deposits. These hydrothermal processes produced beautiful agate and chalcedony deposits in gas bubble cavities, as well as native copper mineralization in some areas. The town of Ballymena sits on an area where these hydrothermal processes were particularly active, leading to local mining operations in historical times. Northern Ireland's volcanic rocks are part of a select group of large igneous provinces, lips, found worldwide. Similar flood basalt provinces include the Deccan Traps in India, the Siberian Traps in Russia, and the Columbia River basalts in the northwestern United States. The North Atlantic province is relatively small compared to these giants but is particularly well preserved and accessible for study, making it crucial for understanding how these massive volcanic events occur and their environmental impacts. While Northern Ireland has no active volcanism, researchers have investigated whether the region's geological structure might have geothermal energy potential. Deep drilling projects have explored whether heat from the Earth's interior could be harnessed through the fractured basaltic rocks, though practical geothermal energy development remains limited compared to more volcanically active regions. Although dormant, the region continues to be monitored for subtle geological changes. Sensitive seismographs detect minor earthquake activity that helps scientists understand deep crustal structure. GPS measurements track tiny ground movements that might indicate ongoing geological processes. Research stations continuously monitor groundwater chemistry for any signs of deep-seated thermal activity, contributing to global volcanic hazard assessment networks. Thanks for watching. Like and subscribe, and don't forget to explore more geological wonders on our channel.